And welcome back. As we go ahead and continue looking at C++, let's go ahead and dive into how to use and operate arrays. So C++, of course, has arrays like many other programming languages. And in C++, the size and the type of arrays that we use cannot be changed after its declaration. And this is very similar, again, to languages like Java. For example, in Java, we have an integer array. It's going to stay an integer array. And the way we do this is we say the data type, the array name, and then the size. For those coming us from the Java background, you'll notice this is a little different in some of the format presentation. For example, you see it says int r5. Int, of course, being the type, arr being the name of that array, and 5 being the size. In Java, of course, it's a little different because of how Java handles the implementation of set arrays. Now in C++, each element in an array, of course, is associated with array index. So, for example, if I were to say r of 1, that would refer to the second element in that index. And just as a couple footnotes related to that, remember that array indices always start with 0. Again, just like many other programming languages, not all, but many programming languages, arrays are typically going to start at the value of 0. And if the size of the array is n, the last element stored is at index n minus 1. So if you had an array of size 10, that means the last index would be 9. And the elements of an array have consecutive addresses. So if you actually look at the array in memory, you would find, of course, each of those elements are stored in memory one after another. Now, when we start talking about array initialization in C++, it's possible to initialize an array during a declaration. So, for example, I can say int x6, and I can set it to 19, 10, 8, 17, etc. I can give it a size value right off the bat. However, if you don't specify the size of the array, as we see here, the compiler will automatically compute the size of the array based upon the number of elements. So if you just say int x, and then you just plug elements in, it's going to assume that that array is exactly the size that you're providing. Now, what's if you have an array with empty members? And what does that mean? Well, in C++, if an array has a size n, so let's say 5, we can store up to n numbers of elements in that array. So if it's size 5, it means you're expecting 5 elements. But what happens if we store less than that number? So, for example, here you can see we have an array of size 6, and we have 3 elements, 19, 10, and 8. Well, what is going to happen is the compiler will see the empty values and is going to initialize them to random and often a 0 value. So, for example, if it looks here, because these are numeric, it would say like 19, 10, 8, and then it would assume, because you're not filling those in, if you plug in 0, 0, and 0. Now, what about insertion and printing arrays? And this is things that we know how to do from our other programming languages. So if we want to change a element in this array, it's pretty straightforward. So for example, I say r of 0 equals 45. That means it's going to change the value at array 0 to 45. So that first index is now changed. If I want to change an element in the array from user endpoint, of course, obviously I can just use in, and I can direct it to that specific element of the array. Now, of course, could you say instead, hey, well, what if I want to put it in a variable first and then put that variable in an array? You could do that as well. Anything that we can do in those other programming languages, we have the ability to do here. If we want to print out an element from the array, obviously we can use cout to specific elements. So in this case, I have r of 2, which means that second element in that array will be printed out. Now, I want to navigate the entire array. This is something, of course, that we do quite often in programming, is we might need to print the array, or we're going to use it in some kind of calculation. We can either use what is a for loop, or what's known as a range for loop, which is kind of like our for each loops to navigate an entire array. So if we use a for loop, and you can see it's pretty simple and straightforward. We would simply say, in this case, we're just printing out those elements of an array called numbers, and I say cout numbers of I, and then we're just printing a space just to kind of space out those numbers. You, of course, can see how that is going to pull those different elements in, because what it's going to do, it's going to go for each element using position I. So that means we're starting at index 0, so print out the 0 value. Then it's going to increment, go to position 1, print out the value at the first index, and so on and so forth. And then with a range-based for loop, you can see we're doing the exact same thing here, but we're using, again, a slightly different syntax. Both of these, of course, would accomplish about the same thing here. Now, there are, of course, times when you want to use one or the other. And when we look at our example here, we're actually going to use the first with our basic for loop to go ahead and handle some of that processing. But a couple of things to kind of keep in note here, of course, is multidimensional arrays. Multidimensional arrays, of course, are arrays that are effectively arrays within arrays. And if we have an array with an array, we remember this is a multidimensional array. So in C++, we can say like int x 3, 4 means that you would of course have those this is a 2-dimensional array. We can of course go to 3-dimensional arrays, 4-dimensional arrays. We can theoretically keep adding on. Most common ones, of course, if we're talking multidimensional, will probably be 2-dimensional or even the occasional 3-dimensional array. Now you can initialize a multidimensional array as follows. So for example, in this test array, you can see that we have set up this so that our first inner array is 2, 4, 5, and separating that with a comma. And then our second one is 9, 0, 19, and that is here. Again, inner curly brackets here to show where that array is beginning and ending. Now, if you don't put those in here, it's not necessarily going to give you compile error. Instead, it's going to assume where you want those values to be. But it's always better to be much more explicit with your curly brackets, and also it's going to be easier for you, the programmer, to read. Now, what about arrays as a function parameter? Because a lot of times we might need to plug an array into a function parameter. Well, the syntax for passing an array to a function is as follows. Return type function name, data type, array name, array size, and then execute some code. So for example, in this here we have int total. We have an integer array called marks of size 5. We're going to pass that in, and then we're going to execute some code. So in here, we go ahead and look at Visual Studio with an example of that. I've created in my main a integer array of size 5. And I'm asking the user to enter 5 numbers to be stored in that array. We have a for loop, which is going to process input for that. And then we're going to, of course, print out an average. And of course, average is a function up here. And find average, what does it do? Well, it takes in an array as a parameter. So we have to plug in this argument here, and that's going to, of course, simply just do a very basic average calculation. So we have our total is 0, and we're going to simply go through that, and every time we go through the elements of that array, we're going to add whatever's in that current element to total, and when it's done, it's going to take total divided by 5, because we know that this has to be an array of size 5. So let's just go ahead, give this a quick run. And I'm just going to go enter in 1, 2, 3, 4, and 5. Hit enter. And you'll notice we get the average of the numbers entered is 3. Because if you think about it, 3 is, of course, the mean value here for those inputs. And that is a real quick demonstration of how we can use arrays. Again, this is something that's very similar to what we might already know from our previous experience working with objects like arrays. And again, they're not much different here in C++.